Okay, so first thing I want you to do, just a quick bit of review before we get into area of a circle. I'd like over on the little circle that I've drawn for you up on the top, kind of right-hand corner of your page, I would like you to, you don't have to be super precise, but use a ruler to make it straight lines. Draw a radius, okay, and also draw a diameter, okay. So if I'm going to do this, something like that is my radius. And again, I'm not using the ruler because that's pretty hard with the mouse. Something like this would be my diameter. Remember, the diameter goes right through the middle. Radius goes from the center of the circle to the edge anywhere, right? So if we think back, in fact, to circumference, we've got two formulas we could use to find circumference. We could have circumference is equal to pi times the diameter, or pi d, or circumference is equal to 2 times pi times the radius, or 2 pi r is how we would often read that formula. There we go. All right, now, when we look at the area of a circle, it also uses pi as part of the relationship. And so if we were to look at the area of a circle, we would find its area using a formula. And area of our circle is going to equal, I'm going to write this out two ways. They both mean the same. Pi times r times r. Or area, and this is going to be the way you more commonly see it, equals pi r squared. What does that squared mean? Well, the little 2 means that we multiply the radius by itself. Not pi times r times pi times r, but the radius times itself multiplied by pi. Area is always measured in square units, and so our units, for example, this question here, are going to be centimeters squared. Now, obviously, this formula is going to give us how many square units. You'll notice circles don't have straight line edges, but if we were to take those square units and break them down, that's when whatever we come up with, that's how many we're going to find that covers the entire portion of the area or the footprint or the amount that that circle covers. All right, so Mei Ling has a circular mirror in her bedroom. Radius of the mirror is 20.5 centimeters. All right, what do we have to do? We got to estimate the area, calculate the area to the nearest tenth of a square centimeter, and then find the area to the nearest hundredth of a square meter. So, not hard to do. I'm going to scroll down just a smidgen here. So, estimating. Well, estimating, it does not just mean guess. Oh, it's about 20. Well, no, there's our radius, 20.5 centimeters squared. Estimating, we're going to use the formula, but we're going to just round stuff to make it easy. So pi is going to be about 3. All right, so again, our formula, I'll write it down once here at the top. Area equals pi r squared. All right, so area is going to equal, estimating wise, pi is about 3. It's actually 3.1415 and so on. We're going to just use 3.14 when we're doing the actual calculations, but pi is equal to, we're going to say is 3 for our estimate times 20.5. Well, that's really close to 20. 20 times 20. All right. 20 times 20, well, 2 times 2 is 4. We've got 2 extra zeros, so that's like 400. Times 3, our area should be close to 1,200. And what I didn't write down in my estimate here is that this is 20 centimeters times 20 centimeters. So centimeters squared. All right, let's calculate it now. All right, so area is equal to pi r squared. Area is going to, now we're going to do this is for part B, calculate the area of the mirror to the nearest tenth of a square centimeter. Okay, so area is equal to pi. I'm leaving this as pi here. Mathematically, this is a number. If you'd rather rewrite it as 3.14, by all means do that. Times 20.5, and I'm going to write my units. I know it's extra ink or pencil lead. Doesn't matter. I want you to get used to writing units. Times 20.5 centimeters. And area is equal to 3.14 times 20.5 times 20.5. I get a final answer of 1,319.585 something. I want tenth of a square centimeter, so that's to one decimal place, 0.6 centimeters squared. In a second, I'm going to redo this again, using finding it to the nearest hundredth of a square meter. We'll get there in a second. All right, so changing this into meters, this becomes 0.205 meters. And we're going to calculate this now. Area is equal to, we already had this down, right? Area equals pi r squared, which again means area equals pi times r times r. So pi times 0.205 meters. And one of the other ways we can write this down is put a bracket around this, because it just include the units in there, and square that second one. So area is going to equal, getting up my calculator, 3.14 times 0.205 times 0.205, 0. Now if I look at my calculator, I'm going to see, oh, this is the same digits as I had before. The decimal places just moved. 0.1319585. Now I want to the nearest hundredth of a square meter. So that's two decimal places, 0.13 meters squared. All right, your turn a little bit. All right, so in this case, you're going to need your ruler. No, you will not need your ruler. Never mind. My apologies. In this case, you are given, again, the radius for both of these circles. And you're asked to estimate and then calculate the area of each circle. So if I take a peek at this first one, well, in this case here, I look at this and go, you know what? I can actually do 8 times 8 times 3 in my head. So if we're going to estimate this one here, area is equal to pi r squared. Well, 3 times 8 is 24, and 24 times 8, that's a hard one for me to do, but if I go 8 times 8, that is 64 times 3. That's a little bit easier. That should be 192. But if that is not math that you can easily do in your head, I can also do a little bit more with this and say, you know what, 8 is pretty close to 10. So area, my estimate, right? Again, my formula, I'm going to use this for both of them. Area equals pi r squared. And here we go. So area is going to equal 3 times 10 times 10, which is going to be about 100 times 3, so about 300 is what I'm coming up with here. Now, is this going to be an overestimate or an underestimate? My guess is that this is going to be an overestimate, because yes, I did drop 3.14 down to 3, but I moved 8 all the way up to 10 and used that one twice. But let's check and see. So, area. But I know my answer should be around 300. So if I pop something into my calculator wrong, maybe I forget the decimal for pi, right? And I start with 314 times 8 times 8. Well, that's going to be very much too big. And then I'd know it was wrong, because that would be nowhere near 300. Centimeters times 8 centimeters. And area here is going to be equal to 3.14. Whoops, I almost did that. Missed the decimal point in my calculator. Times 8 times 8. And I end up with 200.96 centimeters squared. So 200, it doesn't say here to do anything rounding wise, so I'll just write down all the decimal places. Is that close to 300? Well, it's not super close, but it's not wildly more, right? If I had not done the decimal place in pi like I accidentally actually did the first time I tried punching it into my calculator, I would have gotten 20,096. That makes me go, something's wrong. At least here we are, my estimate is in the hundreds. My answer's in the hundreds. Pretty good chance that they're close. All right, so here we go. Radius is equal to 14.8. So now I could round this down. It's close to 10. Right? I could use this same, except it's going to be meters squared instead of centimeters squared if I rounded it down. Maybe I can do like, I know in my head, 15 times 15 is 225. And if I multiply that by 3, that'd be 675. Those are kind of my options here. So I'm going to actually just round down to 10 and know that my answer is going to be a good bit bigger than my estimate. All right. But again, it shouldn't be, like going from hundreds to tens or hundreds of thousands if I goof up. So area here, 3.14 times 15 times 15. And this is, again, just my estimate. Oops, so I shouldn't have the 3.14. My apologies. Scroll it up. There we go. And this should give us 675 meters squared. Right, so, or, 300 meters squared. This is going to actually be pretty close, right? Because I rounded 14.8 up. I rounded 3 down. It should be close to that. Let's check and see. Area equals 3.14 times 14.8. That's supposed to be a decimal point. That looks more like one. Not centimeters. Oh my goodness. All right. And this is the way I'll punch it in my calculator, which is why I'm writing it this way. Another way, I guess I could have written this, again, just to show you, if you don't want to write as much, area equals pi times, and then in brackets, 14.8 meters squared. All right, so that's probably what I write down, but this is what goes into my calculator. Much easier than trying to use the squared button and get order of operations right. So here we go. 3.14 times 14.8 times 14.8, and I get 687.7856 meters squared, which you can see is actually very close to my estimate here. All right, so moving on. We can do much the same here with a couple more. Whoops, just 2 more examples here. So we've got John is cutting a circular hole to go ice fishing. The diameter of the hole is 25 centimeters. Estimate and calculate to the nearest tenth the area of the circle. We got to be careful with that because this is not the radius. This is the diameter. So how to go from diameter to radius? Well, radius is going to be equal to diameter, that's supposed to be a d, divided by, oh my goodness, 2. Which is the same as, I guess, if you wanted to write it this way, more fraction like, d over 2. All right, so area equals pi r squared. As my estimate goes, 12, it's pretty close to 10. 3 times 10 times 10, about 300 centimeters squared. It's going to be bigger than that because I'm rounding down. But here we go. Pi times the radius is, again, 12.5 centimeters. How did I get that? Again, I took my 25 divided by 2. So I can use this little formula here if I want to, right? Radius equals 25 divided by 2. Or I can just do that. In this case, it's one I do know and can do in my head, and most of you can as well. But if you want, radius equals 25 centimeters divided by 2. Radius equals 12.5 centimeters. That's my number that goes there. So pi times radius squared, so times 12.5 centimeters times 12.5 centimeters. Area equals, and this is what I'm going to be expecting to see, formula, there it is, substitution, and solution. So FSS. Formula, substitution, solution. Area is equal to, and this is where I write out my final answer, so 3.14 times 12.5 times 12.5, and I end up with 490.625. Nearest tenth at once, so 490.6. Now, you should be doing these on your calculators if you haven't been up till now. Pause it and actually double check that you can come up with this answer as well. I'm quite serious. Make sure you actually do that. All right, so my estimate again that I knew was going to be low was around 300. Again, it's quite low, but in this case, I know, okay, well, it's probably good because I'm in the hundreds, and this is also in the hundreds, which is good. All right, moving on. Last example. Estimate and calculate the area of this circle. All right, so my first thing I want to do is change my radius, or find my radius from the diameter. So 6.8 divided by 2 is going to be 3.4 meters. That is supposed to be a decimal point, not a part of the 3. All right, so there we go. 3.4, pretty close to 3. So area is going to be, okay, pi r squared. So pi times r squared. So estimating, well, pi is about 3 times 3 times 3 is about 27. 27 is going to be low because everything's rounded down, but again, my answer should be in the tens. If I end up within the thousands or something goofy like that, I've probably missed a decimal place in my calculator. So here's my formula, now my substitution. Now you might say, Mr. Parker, come on, you are not putting in the number 3.14 for pi. Well, I am, because pi is actually representing a number, and it's the same number every time. So if you'd rather write this symbol instead of 3.14, be my guest. Okay, you do, however, need to write the actual number in for the radius, because that can change from circle to circle. All right. And so area here is going to be equal to pi 3.14 times 3.4 times 3.4. 36.2984 is what I come up with. Usually it's going to be to the nearest tenth. This doesn't specifically say, so if you wrote 2984 at the end, I wouldn't mark it wrong. But you could also round this 36.2984. If we go to the nearest tenth, just it's 36.3 meters squared. Again, we said our estimate was going to be 27-ish, knowing that that's going to be small. They're both in the tens. I'm happy, and you should be happy too, because you get to move on to your assignment. Have fun.